Hi class, I'm here with Mr. Maliki. We're socially distant. Our question is about spark plugs and spark plugs lasting. And just asking you, is it fun to have car trouble? It is not fun to have car trouble. If you would like to ask Mr. Maliki why, that's a true story. So now I'm going to put up my mask, go next door, and make our video about spark plugs and how long they last.
Hi class, I'll talk to you sometime about car trouble.
Here we go, walking down the hall here. See, really walking down the hall. Ooh, it's like I've got one of those selfie sticks. I got a selfie stick. No, I don't. I've got this. I'll close my door. So here, we're doing the following thing, folks. Spark plugs. And some cars have 8 spark plugs. And they have 8 spark plugs. And there's a quality company making spark plugs. And their spark plugs last over 3% of the time. You or somebody, maybe Mr. Maliki, who's handling, wonder what is the probability at least one of them fails? Well, if we're doing the probability at least one of them fails, we're going to have to do 1 fails, 2, 3, 4, 5, 6, 7, 8. That's quite a few problems. There's another fun way to get a great answer. Let's try finding the probability that they all last, And they would all last like this. The probability of this one and this one and this one and this one would be 99.3% times 99.3% times 99.3%. And allow me, if you will, that is 99.3% to the 8th power. And when you do the calculations, it turns out that this number right here turns out that 94.5% of the time, all of them last more than the 2 years. Cool. So if you are wondering what is the probability that at least one of them fails, well, it would be 100% minus 94.5%, because this is all of them last. So this would be at least one of them fail. So the probability that at least one of them fails, there would be 5.5%. Fun, except for Mr. Maliki, who this is not pleased with his vehicle's performance lately, and it's brand new. Here we go. Second and final question of ice cream. All are equally popular. None are more popular. 5 people are going to come in randomly. They don't know each other. We don't know what their favorite come in, and they're going to order a flavor of ice cream. And we want to know the problem. 2 people choose the same flavor. Well, it's the same idea as the other one. With people, and the probably 3 people, or the probably 4 people, or 5 people, and that's going to be a lot of work, and especially if we do this problem with like hundreds of flavors and hundreds of people. So let's try this instead. Let's find the probability that none of them pick the same. Now think about this. The first person walks into the store. They've got 9 flavors to choose from. Say that none of them are the same. Well, I hope this makes sense. The first person, 9 out of the 9 choices that person picks will not be a repeat. Here comes the second person, randomly knows nothing about the first one. Well, they've not run out of ice cream, and that person has, let's see, if we're hoping that they don't choose a repeat, there would be, unknown to them, there would be 8 that they could choose from that are not repeated. Third person comes, we have not run out of ice cream. I'm hoping that we pick that no one repeats, no one picks the same. Well, there would be 7 less that would fit that category, and you get the idea. There's a 9, you get the idea. And cool as this turns out to be, this turns out, 98765, it turns out to be a permutation out of 9. That should be a P, a permutation that you choose 5. And the bottom is 9 to the 5th power. That's sort of neat. That's the way it works. So if you got huge numbers, and it turns out that 0.6, the probability is 25.6 that none pick the same. So then our original problem, what is the probability that at least 2 people do? Well, here's the same. So if we go 100% minus that, and I believe that is about 74.4% would be the probability. All right, those are sort of fun problems. Good luck.